There we go. Microphones work better when they're turned on. So, last week we had time to work in class. We all kind of voted, said, I'd like a little more time with the graphing stuff. Y'all should have that very last page. What does it say, like 1.7b or something? Or maybe it just says 1.7 graph practice. So, I'll bring that up here quick, and then if we have any last minute questions on it before we head into review mode, come on, Frank, go faster. Shoop. There we go. Okay, you go bye-bye, you big. All right. So next to every single one of these, you should have a table. And your graph should look something like this. This. Maybe a little off-road if you were feeling adventurous. This. This. This and this. Okay, check the first three, how we feel. Remember, you should have a table next to each of these. It doesn't matter whether you can do this by good old slope-intercept. If you remember that from last year, that's great. That's going to help you when we get to all of the line stuff. Because we're going to do lines, we're going to do systems, word problems, with all that stuff. But that'll be towards the end of this semester, beginning of next semester. But we need to know how to do stuff by table. You have to know how to do by table because that's our fallback option. That is our nuclear deterrent. This is, if I can graph by table, I can graph anything that's got a variable in it. Any of these go wonky on us? Need to double check? 26. Okay. 26 I would have chosen because of that denominator. From -5 to 5, I would choose y values, or x values, that go by 2's. -4, -2, 0, 2, 4. When you plug them in your calculator, you have 1/2 parenthesis x plus 3. And y'all remember where your fraction button is. If you have a scientific calculator, you've probably got a ABC button or a box over box button. If you're rocking one of my graphing calculators, then it's alpha y equals, brings up that menu. So I would choose any evens for number 26. 26, 27 is what I think a lot of kids were asking about, just because fractions are tough. Again, between -5 and 5, going by 4s, -4, 0, and 4, you could go to -8 and 8, but then you'd have to change your x-axis to go by 2's so that you could fit all of it. Or you would just have 2 points that are off-road, like they're off the map, so don't bother. Okay. Now, a good number of you had to ask about 28 through 30. And then when you found out, you're like, oh, wait, that's really easy. Okay, this is the Groot of the math world. See, if I look in here, there isn't an x at all. So if I say x is -2, -1, 0, 1, and 2, the equation doesn't care. X is -2, I am Groot. X is -1, I am Groot. Now repeat the instructions back to me. I am Groot. It just says the same thing every time. Y is 2 no matter what. You connect those dots and it's just a horizontal line. I hope next to these you wrote yourself a little note that if I ever see x equals number, that's a vertical line. If I ever see y equals number, that's a horizontal line at that number. That's it. We expect them to be a lot more complicated than that. Like, we're used to these being more complicated than that, but it wasn't. 31, 32, 33 involve a little more thinking. 31, I would distribute getting -2 plus x and then make my table. Okay, call it good. And 32, 33, we had some concerned citizens who were wondering, why do I keep getting fractions? I did the thing. You remember why? Why do those ones have fractions? Why do these two have fractions? Even if you choose to go by fours, but the ones right above those didn't. Because then I add a fraction. Regardless of what you do with x, you're still going to add a fraction to it. And that's what made all of your points end up partway through the box. So you add point here, 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 depending where you, depending what numbers you chose. Every one of the points, unless you wanted to choose fractions, that would have worked, by the way. If you had put in 1/2, then 3/2, then 5/2, then 7/2, like that would have done the trick. You're going to have a bunch of points that are halfway through the box. Same over here. 1, 2, 3, 1, 2, 3. And then you still only had 3 points that even fit in the box without changing the scale. Like so. But they're all going to be partway through the box. Okay, so that's what we did last time. Y'all said you would rather have a little more practice with that before doing a test. Today, review quiz. I severely doubt it will take us the entire period. So when you are done with your quiz, now I want you to go do the progress check 3 in that packet. Okay, not the chapter test. Don't worry about that. But the progress check 3 in your packet. I do want you to go back and do that when you're done with your quiz today. Okay, because it won't take us all the entire period. So, here we go. Start off with a little bit of review. Okay, when we were talking about section 1.4, we talked about how do I simplify things. Simplify radicals. If you're really good. I got some kids who are good with their mental math, and they know the perfect square, the biggest perfect square that goes into 48 is 16. And This is not even, so I can't do my cut it in half trick, so I'm going to split 1x off of the herd and then work with it. If you do, square root of 16 is 4. Square root of x to the 10th is x to the 5th. That's it. You just, what's outside parties, what's inside parties. I would bet out of the entirety of the two classes, 30-ish kids, I'd bet there's probably only 2 or 3 who could do that consistently. Okay? You got to be really good with your number facts. For the rest of us, do you remember how? It's been about 2 weeks. Yeah? Get that factor tree. I know it's divisible by 2. Okay? And you just keep going. Divide it by 2 until it doesn't work. Then divide it by 3 until it doesn't work. Then divide it by 5. Then 7. Then 11. You break it up with that factor tree. You say, I know this is 2 and 12. I know this is 2 and 6. I know that's 2 and 3. And you break it up. Big kahuna. You take everything that's at the ends of the branches. You, and you. And then the 11 x's. You write them all out longhand. You say there's a 2, a 2, a 2, a 2, a 3, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 x's. Looks like lambda. And then what? If I break it all up, like Tony Stark doing his little 3D map thing. Oh, did I miscount? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, it's 11. I like that you're checking me, though. We were up from about 1:15 to 3:15, and then I've been up since 4:30. So, baby bear sick. Baby bear screamed a lot. So, you circle pairs. There's a pair of 2s. They rush the guard. Only one gets out alive. There's a pair of 2s. They rush the guard. Only one gets out alive. A pair of X's, pair of X's, pair of X's, pair of X's, pair of X's. Put that on auto tune. I'll make millions. 1, 2, 3, 4, 5 X's are coming out. Okay? You circle pairs. Because 2 times 2 is 4, square root of 4 is 2. This is just leaving it in its prime factor form. Just like here, oh, almost forgot there's a 5 hanging out here. So all this stuff comes out, which is the same as 4x to the 5th, regardless of which path you take. You have a 4 and a 5 on the outside. That's 20. You now have 5 x's on the outside. You've got a 3 and an x inside. You do all that and get a 4 out of 5. Yeah? That's why you'd get a 4 out of 5. Remember, they set the precedent of having a plus minus. So your answer needs to have a plus minus. Okay? So I don't care which path you take. If you're going to do like orange, yellow over here, or if you're going to do blue, purple thing, you don't have to do both. I'm showing you depending on what you are comfortable with. Both of those work. Does everyone still have a multiplication chart on hand? Like, you can use those if you want. You don't have to use a calculator if you're more comfortable with physical proximity and lining things up. That works too. Okay, so I have that on here because we need to review it, keep it fresh. We also need to keep reviewing those exponents. They're going to be coming back all year. Okay, we got to know them before heading off to geometry. So step one was if I have stuff inside of parentheses and then an exponent on it, I need to deal with that first. Do I have that? Exponent on a parenthesis. No. Step two. You put turtles next to turtles, giraffes next to giraffes, penguins over penguins. Okay? And this one is already nice and lined up for me. You see number is over number, x is over x, y is over y. So I don't have to go rearranging anything. That's nice. Step three is I'm going to simplify that as much as I can. Remember, if I have a to the 4 times a to the 5, that's a to the 9. I'll add exponents. Or if I have b to the, 5th over b to the 2nd, that's b to the 5 minus 2. Okay, we have those rules for exponents. So I'm going to look up here and say 8 over 14. I can just subtract that and say, what's 8 minus 14? What is 8 minus 14? Press the button on your calculator. Thank you. If you don't have a calculator in front of you, you're in a math class. Why don't you have a calculator in front of you? And your y's, I'll take 10 minus a negative 3. Be careful. Remember, minus and negative are different buttons on your calculator. 10 minus a negative 3. Remember, add the opposite. 10 minus negative 3, you add the opposite. Okay. Step 4, if you have any negatives, you better deal with that. If I have x to the negative a, it goes downstairs. Now it's positive. Or, if it was downstairs and downstairs and negative, bring it upstairs, and it'll be positive. Do I got any negative exponents I got to deal with? Yeah. That x is way too negative, so send them downstairs. I'm now at 30 y to the 13th over 18 x to the 6th. Now that's downstairs, it's positive. And the very last thing, double check if you can deal with any numbers. Like if I had 5 over 10, I would call that 1/2. If I had like 3 to the 2nd times 2 to the 4th, I'd have to turn that into 9 times 16. And then figure out what that was too. So that's, you have to deal with the number stuff. I got number stuff I can deal with. I have 30 over 18. Do you know what number goes into 30 and 18? 6? What if I chose 2 instead? You see how 15 and 9 still have a 3 in common? You keep going until you can't go anymore. Okay? What Clayton did was the greatest common factor. Instead of going by 2 and then by 3, he just says, screw it, I'll do 6 right away. Okay? Like, why chase them around the map going pew, 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 pew when you can just, from long range, done. Okay? Greatest common factor works a lot better. There's your final answer after you've cleaned everything up. We've got a 5y to the 13th up top. We've got a 3x to the 6th downstairs. Now, you don't have to go through every single piece of those steps. How many of you can mental math your way through that after, fighting with them for almost 2 months? Grab a calculator and do 30 over 18. Enter. All right, that's 5 and 3. You look at your x's and say, who's got more game? This guy does. Got 6 more x's. And look at those and say, that's going to have to go upstairs, and then when they go upstairs, I'm supposed to add them, so that's going to be y to the 13th. Oh, wait, I didn't have to do any of this because I've been here long enough. I know this. If you can, go for it. All right? You do not have to write all that out. You do not have to have all those steps. I'm just going to go through it every single time that we go through, hey, y'all remember exponents? You're like, God, it's been like 5 months, dude. And I'm going to say, too bad, we're doing it again, because I want you to know it. At a certain point, everyone in here hopefully should be at, yeah, I get it. That's the point. I want you to get it. I want you to roll your eyes, kind of get it. Okay? All right, so that's all old stuff. Then we hit sections 1-5 plus. Domain and range. Do you remember what domain and range are? X's and Y's. If you don't know that, boy, would I write immediately next to that X's and Y's. Maybe I'd even write input, output. This looks an awful lot like a graph. I'm in a room full of, like, half of you are dyslexic. So, what should we put right next to this? Isn't this a new piece of paper? There it goes. Lisa's grabbing it, right? X, Y, and right next to it, minus plus, up, down is plus, minus. Okay? If you need it, use it. If you don't, don't. I'm just providing you tools so you are fully supported. Now, some of us could just come down here and say the domain is this, the range is this, and we can just start writing. We don't need any of this extra stuff. But for those of us who sometimes swap x's and y's or we goof our negatives, I would put next to every single one of these what the coordinate is before I tried to write out my domain and range. Like that. Okay? Keeping this stuff in mind. Coordinate B goes left 4, down 3. Use these to guide you. Left 4, minus 4 in the x spot. Down 3, negative 3 in the y spot. Okay? Let that thing guide you. And then, for my domain, well, we said domain is x's. So I'm going to look at all the x's. I'm going to list them out. Negative 4, negative 3, 0, 1. I close my little squiggle bracket. If you are not an artist, don't worry about that squiggle bracket. As long as it's kind of squiggly and doesn't look like a 3, we're good. Go check your y's. My y's, my y's, my y's, my y's. And I'm going to write negative 3, negative 2, 0, 2. Oh, that's 1 comma, I swear. Close your little squiggle bracket. You're done. That's it. It's just list the domain and range. Are you starting to get to the stage where you don't need to write anything above that graph now? You don't need to write the coordinates. You don't need to write your little cheater next to it. If you don't have to, don't. But if those help you, as we're just doing this one, did you catch yourself? Oh, that's right. If you caught yourself doing that even once, put a note next to it. Tell yourself, use the XY thingy, write the coordinates next to each of the points before starting. Tell yourself how to do the test. Okay? We're going to have 3 different types of representation here. Graphs, then coordinates. Every year I have someone in this class, when it says draw a mapping diagram, do not write this. I've got a kid who does this. And they go to 1, 8, and then they go to -6, 21. Then they go to -11, 21, and then they go to -3, 11, then they go to 0, 21. Is that a mapping diagram? No. That's a graph. Don't make a graph when it says make a mapping diagram. Every year I get a kid who will do that. What's a mapping diagram look like? Okay, list out your domain and your range. Under domain, you're going to put all your x's. I like to put mine in order. You don't have to. I'll start at -11, then -6, -3, 0, 1. Then I'll go find all my y's, because that's my range. Y's, 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 y's. And say 8, 11, 21. And then I cross the wires. We say 1 goes to 8. Roger that. -6 goes to 21. Roger that. -11 goes to 21. Roger that. -3 goes to 11. And 0 also goes to 21. That's it. It's done. That's it. I'm looking for, did you list your domain? Did you list your range? Did you cross the wires correctly? That's it. Okay? Oh, before I press the button, is this a function? I'm literally seeing 3 people say no and 3 people say yes. Ruh-roh! What makes it a function? Okay. A domain can't go to multiple ranges. Okay. This is okay. That's fine. Right? I can have more than one Coke button on the pop machine. If I press this button, it keeps giving me Coke. If I press this button, it keeps giving me Coke. Okay, it's doing what it's supposed to. The problem is when I have a domain go to multiple ranges. Now I press the Coke button, it gave me a Coke. I press the Coke button, it gave me Crush. The like knockoff orange soda. Okay. This, bad. That is not a function. I press the button. My microwave turned on. I press the exact same button. The back door of the microwave falls off. It is not a functional machine. Okay. Now you don't have to do that for this, but we are going to talk about functions in a minute, so I wanted to use it while it was here. You just got to make the mapping. All right, now it says, is it a function? Is it? But there's more than one thing going to 6. Different buttons, though. That's okay. I can have a Mountain Dew button giving me Mountain Dew and a different Mountain Dew button still giving me Mountain Dew. That's fine. If you're not sure, write it out. Do -8, -3, 1, 8, 20 real quick, and then say 2, 5, 6, 11, and cross your wires. If you need this, use it. -8 goes to 5, -3 goes to 6, 1 goes to 2, 8 goes to 6, and 20 goes to 11. At any point did I ever do this domain goes to multiple ranges? Okay. It's okay to have multiple things in the Y's, in the range. That's fine. I can have 6 buttons that do the same thing. You ever played any retro games where, like, all it is just move your dude around and jump? There's nothing else. There's not even Mario throwing a fireball. It is literally just move around and jump. So all 4 of the buttons do jump. Well, as long as they don't pause the game, I'm fine. They're doing what they're supposed to. Okay. Now here's the catch. I would say yes, it is a function. And if all you do is say yes, it's a function and move on with your life, you just lost points because explain why or why not. Very simply, every x goes to exactly 1 y. Every x goes to only 1 y. I don't have any that are splitting and giving me double answers. Okay. Now you don't have to do the little diagram off to the side. That was just, if it helps you to visualize it, go for it. That's all I need. Womp, womp. Is it a function? How do I know? Why? Line test. Okay, I see a dot, I'm going to make a line. Only hit it once. I see a dot, I'm going to make a line. Only hit it once. I see a dot, only hits it once. I see a dot, only hits it once. I see a dot, only hits it once. Uh-oh. Were we wrong?
Yes, completely.
Only hits it once. Only hits it once. Only hits it once. No matter what, every one of those vertical lines only hit 1 dot at a time. So I'm going to say, yes, it's a function. And you said the line test. So I would say it passes. There's not that many S's in there. It passes the vertical line test. Now, it wouldn't take much for this to be screwed up. There's a lot of points on here. If I had just one more, like, hiding at the bottom of the graph like this. Now it's not. Now I would say it fails a vertical line test at 1. When x is 1, it hit 2 different dots. Okay? Flip it over. Graph-a-fa. Okay? The first one is just graph the thing. Hey, what should we have next to this? No way! Yes, please put a table next to this. I don't care if you... Okay, I take that back. I do care if you remember slope-intercept form, because that's good. That makes me happy. But in this case, no. Instead, we're going to pick points, and what kind of points should I pick? Okay, we had three kind of rules. The first was to pick on the graph. I want to pick things between -10 and 10 because that's the graph I was given. I want negative, 0, and positive numbers. So I definitely want 0. That's the easiest thing in the world. But 3, if I ever have a denominator, either in front of my x or below it, then I want to pick multiples. So in this case, because I got a 4 as a denominator, I want to pick multiples of 4. Now, I can pick whatever I want. If you want to pick -2, -1, 0, 1, 2, go for it. You are going to get points. They're all going to be fractions. Okay? That's fine. You can still graph that. But I know that a good chunk of you just hate fractions with a burning passion. That's why I have rule 3. I'm going to choose -4, -8, +4, +8. That way I won't have fractions. Even better, you can probably do that by mental math now. What is -8 divided by 4? -2 minus 1. -3, right? You owe me $2, you borrow another one. Okay, what's -4 divided by 4? -1. You owe me $1, you borrow another $1. You're trying to cheat me out of some money there, pal. -2. So, do we need that calculator on hand? Okay. I'm going to have alpha y equals was my fraction, if you're using these. And I would plug in -8 over 4 minus 1. Be very careful about whether you're using the negative buttons or the minus button. Some of us were still goofing that up on Wednesday. Please be careful. See the difference between if I do that versus what if I use the negative button again here? You see this? Look at what happens to it when I press the negative. Okay? It raises up a little bit and it gets smaller. There is a physical difference between a negative and a minus on these calculators because it gives you an entirely different answer. In this case, nothing. Like, bud, what are you doing? Error syntax. Syntax is the way that you typed it. I say go to and it says, yo, bud. You can't do that. Okay? So, what's nicer though, were y'all getting comfortable with the highlight the thing and then just retype part of it? That way you don't have to keep redoing stuff. Turn that into a -4. Womp. Go highlight it. Turn that to a 0. Womp. And you get to see the pattern pretty quick, right? -2, shoved a 0 in there, -1, going up by 1 every time, right? 0, 1. Plot your points. So I'm going to go -8, 3. And then I'm going to go -4, -2. And then 0, -1. And then 4, 0. And then 8, 1. Well, that doesn't make a line. Uh-oh, I might have mixed up my X's and Y's. I'm on a new page. I tend to get things confused. Maybe next to this. I should double check that I'm getting all my coordinates right.
I thought I was wrong.
No. Okay. -8, -3 is back 8 down 3. -4, -2 is back 4 down 2. 0, -1 is no left or right, down 1. Now do they line up? Connect the dots, use the straight edge. Okay. Yes, I know that some of you remember slope intercept. Start at -1, up 1 over 4, up 1 over 4, up 1 over 4, connect dots. Great. Put the table in there. I want you to put the table because what happens in another month or two when I put that next to it? See, right now, our graph looks like this. You know what just this little guy does? Turns it into that. Okay? We have to know how to graph by table because that's coming. And the only way we're going to know how to graph that is by table. Okay? So please, 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 please put the table next to it. Okay, down below that, we spent a little bit of time with this. We saw this a few times. I know y'all don't like word problems. But blah, 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 I'm going to have to graph the thing. And they gave me an equation. Can you graph the thing if they give you an equation? What did he just get done saying? I have no idea how to graph this. Do you really want to go up 4/100ths over 1? Up 4/100ths over 1? Enough times to fill a graph that goes out to 500? Or, how about we choose a table? What kind of numbers should I be choosing? Pick numbers from your graph. It does not make sense for me to choose -2, -1, 0, 1, 2 when my graph is going by, how much is each box worth? 50. Box is going by 50. Why would I choose 1 and 2? Instead, how about I put in 100, 200, 300, 400, How about I pick numbers that are right there on my graph? And then I grab a calculator. What is 0.04 times 100? No. 4. What is 0.04 times 200? 8. 0.04 times 300. Take a wild guess. 12. You see what's happening? 16. Then if I said 500, 20. You see the pattern pretty quick, right? So now plot whatever points you can. 104, 208, 300. It's already off my map. I don't care. Can I make a line between those 2 points? What if I had put 0 in there? What's 0.04 times 0? 0. There's my 3 points. Connect the dots. Now there is another question on here. Y'all put an asterisk next to this. Tell yourself, read the problem. Did I answer all the questions? Ahem. Kristen is making gingerbread cookies using her grandmother's recipe. Needs to convert grams to ounces. The equation 0.04 y equals 0.04x describes the approximate number of ounces in x grams. Use a table to graph Kristen's equation. Do negative x values make sense in this problem? What did they say x was? Well, that's on the graph in the problem. Go find where it has x. Okay, that's one spot that's got x. Where else in the words? Okay, one more spot. We're finding all the ones except the one I want. Okay, grams. You keep hunting around until you find what is x? Oh, it's grams. Does it make sense for me to bake something with negative 200 grams of sugar? Okay, so that's when you put next to this, no, can't have negative food, whatever I'm cooking with. Maybe they're not using sugar. Maybe they're using stevia. Stevia plant extracted. Actually, not bad. Gets used an awful lot in diabetic stuff. No sugar. Still tastes sweet. Okay. You know the drill by now, I hope. Devices go over there. We've got more than enough room. Spread yourself out so there's at least one chair in between you and someone else. You can come up here and use the front table if you need to. Spread yourselves out. Devices up here. Open notes, open everything. Fully supported. If you need either myself or Miss LaCroix to maybe walk through something with you on the review next to the test. If you need one of us to read through stuff, especially that word problem, just let us know. We are more than happy to do that. Okay?